Okay, so here we again continue the first chapter, force, from where we left yesterday. So be ready for the class. Okay, so we derived the formula F is equal to g m1 times m2 upon d square in the previous class from Newton's law of gravitation or Newton's universal law of gravitation, where F is the mutual force of attraction, G is universal gravitational constant, m1 and m2 are masses of the objects, and d is the distance between their centers. Now for defining the universal gravitational constant, we will begin from the formula itself. So we know that F is equal to g m1 times m2 upon d square. Now let us suppose that both masses are of unit mass, means their weight is 1 kg and they are separated by distance 1 meter. Then the force of attraction between them will be F equal to g into 1 times 1 divided by 1 square. When 1 times 1 is divided by 1 square, it becomes 1. So the final equation will be F equal to g. So in which condition we found that the gravitational constant is equal to force of attraction, or we can say that the universal gravitational constant is the force of attraction between two unit masses separated by unit distance. The sentence highlighted by the yellow marker can be written as the definition for the universal gravitational constant. Okay, now for deriving or finding the SI unit of universal gravitational constant. Again, here we start from the formula itself. We know that F is equal to g into m1 into m2 upon d square. Now when we interchange them, we'll get g is equal to F times d square upon m1 times m2. Now after this, in the next step, we'll write the unit of respective terms used in the first case. For example, the SI unit of force is Newton, so we'll write N over here, and the SI unit of distance is meter. Since here is distance square, so it will be meter square. Similarly, on the denominator, we'll write kg square, since the SI unit of mass is kg, and here m1 and m2 both are kg, so kg into kg, it will become kg square. Now in the final, we can say it as Newton meter square per kg square, or it can be also written in the term of Newton meter square kg minus 2, which means also the same. Okay, now for the numerical, we should keep some basic concept in the mind. So here are given some of the concepts. For example, the first one is the mass should be written in kilograms or kg, which is its SI unit. Similarly, the distance also should be written in meter, which is also its SI unit. And the most important thing is that we should know the value of universal gravitational constant, which is 6.67 times 10 to the power minus 11 Newton meter square per kg square. And last but not the least, we should also know the formula of force, which is F is equal to g m1 times m2 upon d square. So these things should be kept in mind before doing any numerical questions. Okay, now we'll go for the numerical. Here is a question. Calculate the gravitational force between two students A and B having masses 50 kg and 60 kg respectively, sitting at a distance of 10 meter on a bench. So in this kinds of question, first of all we have to write what is given. So we'll write it like this: given mass of student A, that we write as m1, it is 50 kg. Similarly, the mass of student B, we write it as m2, which is 60 kg, and the distance between them d is given as 10 meter. And what is asked? The force or mutual force of attraction between them is asked. So force equal to what? That is what we have to find. Now from the Newton's law of gravitation, we know that F is equal to g m1 times m2 upon d square. Okay. So now we'll put each of them's value. For example, g, the value of g is not given in the question. I already told you, you have to know this by yourself. Okay, so we'll write the value of g, which is 6.67 times 10 to the power minus 11 times m1 50 times m2, which is 60, divided by distance, which is 10 meter square. Now for our convenience, we'll multiply the smaller terms like 6.67 with 50 and again multiply it with 60. We'll leave the power of 10 as it is. So when we multiply 6.67 into 50 into 60, we get 20010 times 10 to the power minus 11 will be as it is, divided by 10 square. Now in the next step, we'll try to bring the power of 10 upwards. So when we bring a digit from denominator to numerator, its sign changes. So since it is power 2, it will be negative power 2 in the next step. So when minus 11 minus 2 will be added, it will be 10 to the power minus 13 in the next step. Now when we put 20010 in the power of 10, it will be 2.001 times 10 to the power 4, which again is multiplied with 10 to the power minus 13, and the final answer will be 2.001 times 10 to the power minus 9 Newton. Since it is force, its SI unit will be Newton. So before doing the numericals, you definitely need a calculator. So if you don't have, get one. And during calculation, if there is any doubt anywhere, you may ask. So I have given you some questions to solve for you. So here are the questions for you to solve. Their answers are also given at the last. So try to do it by yourself by using the formula and using your calculators. And if there is any doubt anywhere, you may ask me. Okay, thank you. This much for today.